Okay, hello again. So in previous lecture or previous session, we have seen I2C. Let us see DAC now. So we will be communicating microcontroller. So communication between microcontroller and DAC using I2C communication standard. So let us go directly to digital to analog converter, that is DAC. We have already seen DAC in our second year curriculum. So we know that output of digital to analog converter is always in terms of steps. So you can consider this y-axis as analog voltage and your x-axis is nothing but binary value, or you can say decimal. So you can see this output which is in steps. So this particular thing is called as, or this step is called as step size. So also called as resolution. So resolution or step size can be calculated by using this formula. So if I consider that DAC is say 8 bit and my reference voltage is say 3 volt, then 3 divided by 2 raised to 8 will give me this much, that is 11.72 millivolt as resolution. So every step is of 11.72 millivolt. This is what you can see. So you can reduce the step, or you can reduce the step size, you can increase the step size by simply changing the output voltage here, which is referred as output voltage or reference voltage, which you can say 2 raised to 8. This value cannot be changed if your DAC is 8 bit. We have seen various types of DAC as well. So various types of DAC that we have seen is binary weighted DAC or R2R DAC, which we have seen in our second year curriculum. We also know that output is in terms of steps. Now data that is accepted is in parallel form. So data which is accepted is accepted in parallel form, and then it is converted to analog current. So looking at the diagram, so this is the diagram which is where you are interfacing 8051 microcontroller with digital to analog converter. So all 7 pins of your 8051 are connected to data lines of DAC. So what will DAC do is it will accept the digital input and it will convert it into analog. So the output of DAC of 0808 is current. So an amplifier, so an inverting amplifier here is used to convert the current into voltage. So this is acting as I to V converter, and your reference voltage will be 10 volt. So my step size would be 10 divided by 2 raised to 8. So whatever value I'll get, that will be my step size. So this is the interfacing diagram of 8051 with DAC. Now this 0808 DAC cannot communicate with microcontroller, as this is not I2C, and what you can say, it is not I2C compatible, as there are no SDA and SCL lines. So that would be different, which is having SDA and SCL line. Now this I out, that is the output of DAC, is in the form of current. So that I out is nothing but equal to I reference, that is reference current, which is 2 milliampere. D7, D6, D5, D4, D3, all these are digital values which are input to DAC, that is this. And 2, 4, 8, so these are the binaries. So I can simply calculate I out. Once I calculate I out, it becomes easy for me to calculate V out, because V is equal to I into R. R is nothing but 1K, 5K. It depends upon the value of resistor that you select. So current at the output is converted to input using an operational amplifier. So let us see programs to generate few waveforms. So input to DAC would be binary, and then it would generate a waveform. So let us see sawtooth waveform. So 4 volt sawtooth waveform with 5 volt reference. So this peak would be 4 volt. So my waveform will reach 4 volt and it will drop down. Again the output, if you see, it is in the form of steps. So here 64 value is giving me 3.9 volt. So to get 4 volt, my value that I will load in the resistor R0 will be 64. Then I will move in accumulator 00, because I need to increment. I move it to port 1 because my port 1 is connected to DAC. Then finally I will keep on incrementing. I keep on comparing. If I compare, and if it is not equal, I jump back. And in this form, I will generate a sawtooth wave. So this peak is 4 volt, which is achieved by using 64H as hex value. Once I reach here, then again I repeat the same thing. So again I start from accumulator, and that is where it drops down, and again I get this waveform. So if I wish to have some other value, say 10 volt is what is my wish, or I want to achieve, instead of 4 volt now it is 10 volt. In that case, what would be my value? Instead of 64, it would be FF. Then I out would be 1.99 milliampere, and again V out is nothing but if it is 5K of resistor, 1.99 milliampere into 5K, so 9.96 volt. So this is how you generate a sawtooth waveform. Similarly, I can generate a triangular waveform. So this is how a triangular waveform will look like. Again, if you see carefully, it is in the form of steps. So you move in accumulator A, you move that data to port 0 if port 0 is connected to your DAC. Increment, you compare if it has reached FF. If it has reached FF, then this condition is not true, and again you come down, start decrementing. So you keep on incrementing, keep on comparing, and you jump when it is not equal. So at every step it will keep on incrementing, it will reach FF, and then it will keep on decrementing, and your this waveform is generated. So first half is generated by incrementing, second half is generated by decrementing. So this is one period which is generated. Again, to repeat the same thing, to again generate next period, you will have to repeat the loop. So S jump back to loop, and you keep on moving data. So here again loop is not written here. The reason being is your accumulator final step. At final step your accumulator is 0 0. So no need to initialize it with 0 0 again. This is how a sine wave will look like. So sine wave, again it is in the form of steps. So you can generate sine wave, you can generate steps, and so on. So thank you for patiently listening. I hope you have understood I2C and DAC, and you would be able to write program for the same. Thank you again.